right, let's make sure. Yes, music actually stopped on time this time. Good. All right, when last we met, we had two copies of the table. We had the white copy of the table and the black copy of the table. Now, out of your handouts, go get the next page, which is the gray piece of paper. And we're going to start layering in yet another index in here and see how that works. So when we left off, SQL Server was having this challenging discussion of trying to figure out whether or not it should use the index. Like here, it was using the index because our query was totally easy to understand. Cody likes my or Coy likes my t-shirt, thank you. And then this one, SQL Server wasn't smart enough to figure out that it could use the index and go quickly. Our query syntax was causing problems. Well, when you see SQL Server trying to make a decision between doing a key lookup versus a table scan, a classic thing that you see inside of execution plans is a key lookup with some outputs in it. When you see a key lookup with some outputs on it, that means that SQL Server couldn't get everything that it needed from the non-clustered index, so it had to go back to the key, to the clustered key, and go back and grab additional columns. One way that you can fix this is to go add these output columns to an index. Make a wider index that has more things in it. That's where the gray piece of paper comes in. What I've done is I've created an index on last access date and ID, and I've tacked on the display name and age column as well. One thing that you'll notice is that this thing is wider because it has more columns in it. It can't fit as many people per page. These pages have about half as much as this page does. So you can think of it that this index will be twice as large on disk. It's going to take longer to do our inserts and deletes, longer to do our index maintenance and so forth. But if you're willing to make that trade-off, then even the bad quote-unquote query uses it. Here, when people were using the year and month of last access date, SQL Server's estimates are still wrong, but it doesn't matter because he just was able to seek into this brand new wider index and grab all of the columns that he needs. Now this index is physically larger. It does have more 8K pages in it. One way that you can check to see the overhead of that is to run the command SPBlitz Index. SPBlitz Index is part of our open source first responder kit. It gives you all kinds of scripts and tools, and I teach you how to use that in another class coming up, how I use the first responder kit. If I call SPBlitz Index with one specific table name, SPBlitz Index will list out an inventory of all of the objects on that table. Here, in this case, we see that our first initial index, the index on just last access date and ID, that one has all 299,000 rows in the table. It's about 5 megabytes in size. The second index on our table, the one that's wider, takes up more space because it has more columns in it. The more indexes that you have and the wider that they go, the bigger your database becomes, the longer your backups take, the longer your CheckDB takes, the longer your restores take, the longer your index maintenance takes, the longer your update statistics jobs take, and even the less memory that you have. Because if I want to store this object in RAM, it takes up more space than this object would have. Because this is the smallest unit of data that SQL Server works with. He doesn't work with individual rows or columns. If he's going to cache something, he's going to cache whole pages, and there are less pages per, or less rows per page here than there are here. The users table is now going to take up more RAM. When you first get started creating indexes, you're like, go, I've learned that indexes make things faster. Create index like crazy. People follow the database tuning advisor. People follow all the missing index hint recommendations. And at first, it's not a big deal. They create an index because it immediately makes their select query go faster. But over time, your SQL server is just dragging more dead weight around trying to do all these inserts, updates, and deletes and maintain all these copies of indexes. You might be a redneck if you might have too many indexes if people are complaining about slow inserts and deletes. Now let's think about that one right here. You know what? In most shops, they're not. In most shops, people don't complain about slow inserts and deletes. Slow inserts and deletes happen up in the seconds worth of territory because we're dealing with blocking and locking. But if it's taking 50 milliseconds versus 200 milliseconds, you know what? Not a lot of people really care. The place where they care with this is data warehouses. If you have a data warehouse and somebody's like, oh my God, the data warehouse loads are taking forever. And then we go pop open the tables and we look to see we got 24 indexes on every table. That is where they're complaining about slow inserts and deletes. And we may need to peel back some of the number of indexes that we have. If your monitoring tools are warning about blocking and deadlocking, the more indexes that you have, the more that SQL Server has to shuffle around and grab locks across all of them when it needs to do inserts, deletes, and updates. Or if your database size is a problem, if you're trying to get your database to be down smaller, you might want to think about ripping out some of the indexes that aren't really in use all that much. But you know what, for a lot of people, none of these happen. With a lot of shops that I run into, their problem isn't too many indexes. Their problem is that people haven't added enough indexes because they were afraid to, because they thought they were too big of a deal. Generally speaking, I talk about in my Fundamentals of Index Tuning class, you should have 5 indexes per table. That's normal, totally normal. When you get up above 5, that's when you start to ask questions. And we'll dig more into that in the Fundamentals of Index Tuning class. You might not have enough indexes if people are complaining about slow selects, or if you can cache most of the database in memory. That tends to indicate that you've got a lot of hardware, and you could probably live with slowing that down a little bit in order to pay off and make your selects faster. A long time ago in a galaxy far, far away, Microsoft introduced the capability of doing includes in an index so that we could just include columns in the index without having them in the key. I'll be honest, I think that it was mostly due to hardware the way that it existed back in the late 1990s. And nobody runs SQL Server on hardware that crappy anymore. But back then, people said, well, if you only include the columns on the index, it's a lighter weight overhead. It's able to store it differently and it doesn't take up as much space. Really, McFly? Because if I create that index and then I look at the 2 copies of it, the top copy just includes last access date or just includes display name and age, 12.3 megabytes. Here, all 4 columns are in the key, 12.7 megabytes. That's not a showstopper of a difference. To be honest, even if this was gigabytes, that's not really that big of a deal. Because at the end of the day, their 8K pages have exactly the same stuff in it, whether you create the index with all 4 things in the key, or whether you put 2 things in the key and put the other 2 in includes, your 8K pages look exactly the same way. The only thing that's different is the supporting structure of the index, aka the B tree. And that's just not that big of a query performance deal for 99% of the audience out there. But some folks will say, but size is only a small portion of it. The other thing that's big with includes is that they're not having to sort on the index. If some of the data changes, it doesn't really matter. I don't need to resort it as much. Think a little bit deeper about that. Let's say that this user over here in the corner, sarcastic. Let's say that sarcastic got 1 year older and we need to change his age from 30 to 31. If age is only included in the index, then the changes in value of display name and age don't change the sorting. So I could change his age from 30 to 300 and it doesn't make any kind of difference here. This age is only included in the page, so I don't have to change his sorting. But I don't want you to think that that's a lightweight operation, because you know what we still have to do? We still have to pull this 8K page up into memory. We have to change this data. We have to push this 8K page back down to disk. None of that changes. Now, if I put age in the key, if I put age in the key of the index and then he changes his age, oh, this is where people who say they like includes get all excited, because they're like, now if you change his age from 30 to 300, now it's going to make a big difference. Is it really? Take a look at that page, and if I change Sarcastic's age from 30 to 31, where do I move him on this 8K page? Does changing his age change where his row lives? Makes no difference whatsoever. I could change his age to 300 because this is very selective. This really determines where he lands. This is so close to unique, his display name could change. I could change him to Alpha, and it still doesn't change where he lives. I could change his ID. It still doesn't change where he lives. The first column in an index is dramatically important. The first column, generally speaking, needs to be relatively unique. It doesn't have to be perfectly unique, doesn't have to be perfectly selective, but generally the first couple of columns matter a lot. The rest of the columns, order, doesn't really matter whether it's in the key or the includes. I don't want to say always. There are absolutely edge cases where it makes a phenomenal difference. But what I'm getting at here is as long as you get roughly the right columns on these pages, and as long as the first couple of columns are in the right order, you can go a really long way. Generally speaking, columns in the where clause, group by, joins, and ordering, these are often good candidates for your indexing keys. And generally, columns in the select are good candidates to include in an index. Just don't think that includes are magically delicious. They're not. They take up just as much space on the 8K page, and sorting on them doesn't usually matter that much when they're beyond the first couple of columns in the index. So to recap what we talked about inside here so far, generally the less columns that indexes have, the less benefits there are. If you have a bunch of single column indexes in your database, SQL Server is usually making the tipping point decision really early, and it ends up just ignoring those indexes altogether. Generally, you want more columns in your indexes. I encourage people to think about having up to, say, 5 columns in their indexes, and that'll end up giving you more payoff for queries. It does cause bigger indexes, longer maintenance jobs, and more blocking, and we talk about the trade-offs between these in the fundamentals of index tuning class. And then included columns just aren't simply magically delicious. Now, we're coming to the end of this, and I'm going to switch over into questions and answers, but I always want to tell you where you should go next whenever you finish one of my lectures. If you go to brentozar.com/go/engine, you can download this exact slide deck, and there are resource links trickled all throughout saying if you want to learn more about stats, for example, go to my statistics class. Then after you go through the related resources, my Fundamentals of Index Tuning class is a one-day class designed for people who need to design indexes for queries without looking at the execution plans. In there, we really focus on how do we write indexes without looking at plans. Then my Mastering Index Tuning class teaches you all the edge case gotchas, filtered indexes, partitioning, indexed views, and much more. Or if you're the kind of person who wants to learn query tuning, my one-day class on Fundamentals of Query Tuning teaches you more about how SQL Server builds query plans, how you should go about finding the right queries to go tune, how query parameters influence which plans get cached in memory, and then a few common T-SQL anti-patterns that if you steer away from those, your performance will be much better. After you finish that one, you're ready for my 3-day online Mastering Query Tuning class, where we go much more in depth about doing things like advanced rewrites, CTEs, and so forth. So let's hit your questions here. So let's see. Greg says, what are the advantages to creating unique indexes? One of the big ones is that if SQL Server knows that the combination of columns will be unique, it can reliably estimate that only one row is going to come back. Frankly, that's not that big of a benefit for me, because usually even without declaring the index as unique, the statistics will give SQL Server enough of a hint that it's going to estimate really close to one row, like it'll estimate 1.000 something. Calling the column or calling the index unique just guarantees that the estimate will be exactly one row. I've never had a situation where that difference got me across the finish line, but I know folks who have. The other benefit for it is that if you need to enforce uniqueness at the database level, like if you don't trust the code that's inserting data into the database, just know that there's a performance overhead for that when you force SQL Server to do that uniqueness check for you. Next up, Tim Bolero says, I'm missing the recap pictures with caps in them. Yes, that is in the Fundamentals of Query Tuning class. I was very proud of that. I try to do different themes of stuff the whole time. Adam says, this may be way out of the scope of this session, but how should I best approach index creation that we've covered when devs are using Entity Framework and there's less control over the terms of the SQL that's thrown out? So my honest thought with that is that even when you think that you have control over the T-SQL, you don't really have control over the T-SQL, do you? Like, people are going to write, haters are going to hate, and developers are going to develop, and users are going to use. People are going to write heinous queries, whether it's in Entity Framework or whether it's in stored procedures. You really approach index creation the same way. It's all about making sure that you have enough indexes to make your queries go fast, but not so many indexes that they slow your queries down. Marcus says, are there cases where a view on an index table does not benefit from the index? So yes, depending on what's in the view, the problem isn't the view itself. The problem is the T-SQL in the view. For example, I've seen people put in like 15 group bys. Group by this and this and this and this, having this and where this. And they're asking for all kinds of extra stuff that they don't really need. And SQL Server's like, oh my God, you have so many columns inside here. I better off just scan the table. So really the problem in there is more about the query in the view. And to give you a great example, copy paste the query straight out of the view and try to run it by itself with whatever where clauses you need inside there. And usually you don't get the index usage that you want in there either. Again, to emphasize that it's not the view's problem, it's the query inside the view. I have clients using a ton of views, then they have great performance, but because they tuned the bejesus out of the queries inside the views. Shazad says, does the first responder kit work with Azure SQL DB? Shazad likes to ask questions without reading the documentation, like reading the README. Shazad, I love that. Thank you very much. I know that this audience is going to think that I'm going to burn you for not reading the documentation, but let's be honest. My favorite students are the ones who read the documentation who don't read the documentation. Because look, we're all here in a training class because y'all won't read the documentation. Because the documentation is dry and boring, I don't really like reading the documentation either. So Shazad, does the first responder kit work with Azure SQL DB? Some of the scripts do and some of the scripts don't. The problem is that Microsoft keeps changing the contents of the DMVs and which things are supported, and there's no change log for what gets changed, so I gave up trying to support it a long time ago. Parts of them work, parts of them will not, but don't bother filing an issue on one of them not working unless you're prepared to put in the work to make it actually work. Otherwise, I love the idea of Azure SQL DB. I just don't have hardly any clients actually running Azure SQL DB. Just the cost of it is a little bit on the tricky side. Gustav says, asking for a friend, are there any use case scenarios where you would create a non-clustered index on a primary key? Yes, and we talk about those in the mastering index tuning class. So now that's 2 levels up above where you're at now. We just finished how to think like the engine. The next one up is fundamentals of index tuning. The next one up after that is mastering index tuning. I don't say that as an attempt to pitch you on it. I say that so that you understand how rare it is. Like, it's insanely rare that I separate the clustered index from the primary key. I think I could count on one hand the number of times I've done it in the last 5 years. So it's just extremely rare. Binu says, I've seen queries with values directly checking in the join clause instead of the where. How does SQL Server use an index? Oh, that's a great question, and I'm going to cover that in exact detail in my Fundamentals of Query Tuning class. So that one's also coming up in the next few weeks. So search for Brent Ozar Fundamentals of Query Tuning, and we spend about an hour on it inside there. Pro Hiller says indexes are computed over computed columns. Are those also covered in the mastering index tuning class? Yes, they absolutely are. Steve says, we have a very large database, tables with 1 billion plus rows. Developers try to, so here's a pro tip, y'all. When you ask a question, if you can keep it shorter rather than simple. I don't want to know what your birth date is, your mother's maiden name. I'm sure other people would love to know that for identity theft purposes. But if you can just boil down straight to the chase and stop telling me about your childhood. He said, you touched on keeping queries as simple as possible. And here's, after all that, he's got more stuff inside there. Any further useful comments on this? Yes, keep your queries as simple as possible. Try to rephrase your question, and maybe we can boil it down a little bit there. Maro asks, can it make sense to have your clustered index on a GUID column instead of on integer IDs? Yes, and we cover the use case for that in the mastering index tuning class. Again, the fact that it's 2 levels up, like you're in for how to think like the engine. Next up is the 1-day fundamentals of index tuning. Next up is the 3-day mastering index tuning class. The fact that it's in mastering kind of tells you how fairly unusual that is, that it isn't something that you should have to do fairly too often. Next up, Kairu over on YouTube says, if there's an unnormalized table with many columns, should we create different indexes for different use cases, or is it better that we split the table? Kairu, that is a great question. I mean, like, a lot of y'all ask good questions, but Kairu's one is actually great. So the problem with splitting a table up into different groups of columns is that generally you have to rewrite places of your application. People get pissed off when I tell them to rewrite their app. Like me as a consultant, my primary job around here is doing consulting and doing emergency performance tuning for companies. If I came in as a consultant and said, you need to change your application, we're going to split this table up into 3 parts. Just rewrite all the queries that touch this table. Bye. They would kick me out before I would even make it to the door. Instead, what you want to do is think about how this is a really wide table and this is a narrower subset that's designed for specific use cases. This is really like paying for architecture problems that you didn't get right in the first place. In the perfect world, we would architect this beautifully and break it out and normalize it. But if you can't, then this is a really easy fix for post-production. Sai says, will it still help to include almost all of the columns, greater than 5 columns, in a normalized table? I assume you mean in a non-clustered index. It absolutely can, depending on what your first columns are, yes. Prod says, I used to get complaints from the team saying that inserts are slow. I checked the number of indexes and it's 3 and it doesn't have any large columns. The queries are straightforward also. Is there a way that we can improve an insert? Yes. When you're having slow inserts, there are several things to think about. One is blocking. Is someone doing a begin tran and then doing all kinds of work across all kinds of different tables? You want to keep your transactions as short and sweet as possible. Kind of think of it like going to the grocery store. You would never go to the grocery store, go get a cart, and then go to the checkout line and say, all right, I'd like to begin my transaction. Now, if you'll excuse me, I got to go get some lettuce. Also, hold on, here's the lettuce in my basket. Now, I need to go find some lemon juice. I'll be right back. The other shoppers would beat you to death in the grocery store. Instead, what you do is you go get all of the stuff that you need, and then you begin the transaction, and you get out as quickly as possible. So that's another thing to think about. Then finally, the other thing to think about is the speed of the writes on the SQL Server itself. If you have things like synchronous always-on availability groups, database mirroring, slow storage, all of these things can slow down your inserts as well. Nathaniel says, is the correct order of columns in multi-column indexes covered in the mastering index tuning class? No, that's actually in the fundamentals of index tuning class. You know, it's really funny when I pick and choose things that are going to be in fundamentals versus mastering. I think that the which column should go first in an index is really fundamental. But I know so many database administrators and performance tuning people who come waltzing into my mastering classes and they haven't taken the fundamentals. And I'm like, okay, so in this exercise, you know, you got the order of columns wrong. So tell me how you chose the order of columns in an index. And they go, selectivity? And I'm like, nope, you fail. Go back to fundamentals of index tuning. You miss the basics because selectivity of the data in the table has nothing to do with it. We cover that in fundamentals. Suresh says, thanks for the lovely session. You're welcome. Anders says, if it makes no difference to use includes or not in an index creation, why does SQL Server suggest indexes with and without includes? So SQL Server's missing index recommendations are calculated in a matter of milliseconds. You and I, us meatbags, we take hours to do that. SQL Server's trying to pull it off in a matter of milliseconds. So he just can't afford to put too much thought into it. They're a starting point. They're not a finishing point. And in fundamentals of index tuning, I'm going to have some world-shattering news for you around how those indexes are created and what their order means. It's not what you think it is. All right. So, thanks, y'all, for the kind words over in the comments. Thanks for hanging out with me this morning. So I will go ahead and stop here. Lots of other questions are starting to come in now once I talk about bailing out for the day. But I will see y'all in the next free classes. So next we have coming up over the next couple of months, we have how I use the first responder kit, fundamentals of index tuning, fundamentals of query tuning, fundamentals of parameter sniffing, fundamentals of TempDB, all kinds of one-day classes, all in the same kind of user interface as this. So if you liked one, you're going to like those as well. This is the shortest one out of everything that I do. The longer one, the rest of the ones inside the next 2 months are all going to be all-day courses. So thanks a lot, y'all, and I will see y'all in the next class. Adios.